Hey guys, welcome back to my channel and I'm back again with another really interesting coding interview question video this time guys. We are going to solve question number 654 maximum binary tree, which is a medium level question of Leetcode. So without wasting any time further, let's get started with the problem statement. So basically guys, the problem statement says that we are given a integer array, and that integer array guys is having no duplicates, and you want to build a maximum binary tree with it recursively. And let's look at the algorithm later, but let's look at the input first. So you can see that this is the array and it's obviously no duplicates, and you want to create a maximum binary tree with it. So what is a maximum binary tree? So this is the algorithm for maximum binary tree. Maximum binary tree means that we have to create a root node which has the maximum value in the nums array. So for example, in this case the nums array was having these values, and you can clearly see that 6 is the maximum value. So 6 is the root node, and afterwards we have to recursively build the left subtree on the subway prefix to the left of the maximum value, and same for the right. So just to explain it a bit more easy way, so first we have to find out the maximum value. So 6 becomes your root. Now whichever numbers are there in the left of the maximum value, in this case 3, 2, 1, whichever numbers are on the left, they will form the left subtree, and whichever numbers are on the right will form the right subtree. Now out of these numbers also we have to recursively do it in such a way that you can see that 3, 2, 1, 3 is the maximum number, so 3 will become the root, and then when you start aligning 2 and 1, 2 is the maximum out of 2, 1, so 2 becomes the root, and then finally 1 becomes the right side. Okay, and same with 0 and 5. So you can see that in 0 and 5, 5 is the maximum number, so 5 will become the root, and 0 came before 5, so 0 will become the left child. Okay, and in this case you can clearly see that in 3, 2, 1, 2 and 1 both came after 3. So that's why 2 and 1 both are the right child of 3. 2 is the right child of 3 and 1 is the right child of 2, because 2 and 1 came after 3. And because 0 came before 5, 0 becomes the left child. And they are all child because 3 and 5 are obviously maximum value in their own subtrees. Okay, in this subtree 3 is maximum, in this subtree 5 is maximum. Okay. So using recursion, that's what they suggest, we have to first return the maximum binary tree. Okay, and the example is pretty much straightforward guys. You can see that the nums is 3, 2, 1. So obviously 3 is the maximum number, so 3 will become the root, and then we'll start aligning 2, 1 in the right side. We will find out which is the maximum. 2 is the maximum, 2 will become the parent, and then afterwards just 1 is left, so 1 will simply become the right child of 2 because it's coming after 2. Okay. Now the constraints are that the length of the array goes from 1 to 1000, the values of the numbers go from 0 to 1000, and all the integers are unique. So now that we know about the problem statement guys, let's jump to the solution part of it. Now if I just want to clarify the solution on this guys, I think in this particular question they already gave the solution to us, and what they have given us is that we just do a very simple algorithm where we just iterate through the numbers. So for example, we just create a recursive function which will iterate through the numbers, find out the maximum number. So in this case we find out this index is the maximum number index, and then we divide the array into 2. So now the array is divided in this half and the array is divided into this half. And then recursively in their own each halves, we will again find out which is the maximum number. That maximum number will become the left of this 6th node, and out of these two, whichever is the maximum will become the right of this 6th node. And the same procedure if we continue to do recursively, eventually we will land up in creating this tree. Okay. So this solution is already given to us, and what we are going to do is we are going to simply implement this solution in the first part of this video. Okay, so I'm not writing the pseudo code here, I'll just simply go on to implement it. So what we can first do is to create a helper function which is going to iterate to the numbers and give us the maximum array. Let's call it private tree node. So tree node is the node which is going to be the maximum node in that particular subtree that this function will return. And let's also call it construct maximum binary tree, and let's just overload this function. Okay, now this function, guys, which the overloaded function, this function will be called with 3 arguments. The first argument obviously is going to be the nums array. The second argument is going to be the left index, let's call it left index, and the third argument is going to be the right index. So what we want is the maximum number from the left index of the array to the right index of the array. Okay, that's what we want. So the first thing is to create this function which takes these 2 arguments. Now what we need to do is start finding out how to do this node. Okay, so let's first compare if the left and the right index are actually correct or not. So how to check that? If the left index is actually greater than the right index, if the left index is actually greater than the right index, right, it basically means that you have traversed the entire nums array and you have found your tree node already, or probably there is no node in that particular half of the subtree, so you just return null. Okay, now if the left and the right index are same, so if left and right it is equals to each other, then it basically means that we have found that particular tree node which is the maximum node. We have found our tree node. So we just do return new tree node, and then we just do nums L or nums nums left or nums right, whatever you want to do, that's up to you. Okay, so 2 conditions are done. Now the next condition is, what if the left and right are not equal? In that case we will just create an integer which is called the maximum index, and we will by default assign it to left. Okay, now this maximum index is going to find us the maximum element from the left index to the right index. So let's first run our loop. So for integer I equals to left, integer I is less than equals to right, and then I plus plus. And what we simply do is we find out if the number I is actually greater than the number which is at maximum index, then what we do, we simply update the maximum index to I. Okay, we simply update the maximum index. That means after this for loop is completed, the maximum index variable will have the index of the maximum number in the entire array. So in our case, in this example, after this for loop is completed, this maximum index will have 6. So once we know this is the index of 6, the maximum number, now we can divide our array in such a way that all the elements coming before this index will form the left subtree, and all the elements which are after this index will become the right subtree. So first let's create our root node. So obviously the maximum index is my root node. So tree node root becomes equals to tree node, and let's pass in the init function, in the init constructor, nums maximum index. So that becomes my root node. Okay, now what will be the root dot left? Root dot left will be just recursively following the same function, passing the nums array, but in this case we will change the right index and we will change the right index to the maximum index -1. Okay, and then when we will do it for the right hand side, we will just change the left index. So left index will be maximum index +1, and the right index will be the same. And finally, when this entire part is recursively done, we are just going to return the root element. Okay, now in my main function, what I am going to do, I am going to just check if the array is null or not. So if the array is null, or the array length is equals to 0, it means there are no elements in the array, right? So you just return null. It means nothing can be created out of that binary tree. However, if there is at least one element in your array, what we are going to do, we are going to call this recursive function and we are going to pass our nums array, the left index and the right index, right? So left index is going to be 0 and the right index is going to be nums length minus 1. Okay, let's run this code, guys. Let's see if this works for our problem statement. And you can see it's accepted for 2 cases and hopefully this will get accepted for others as well, and there you go. But there are some issues with this code, guys. Although this is the exact same algorithm which is suggested to us in the problem statement, if we talk about the time complexity of this particular problem, we clearly see that because we are using a divide and conquer approach and recursive function, it's pretty clear that the first time this function is called, at least this for loop is getting called n times, right? Because we are traversing from left to right, n elements. The second time this function is called through these recursive functions, it is like in total if you do it, if you exclude the root element, it is called for n minus 1 time, right? So first iteration n times, then n minus 1 times, so n minus 1, and then n minus 2, then n minus 3, something like that, right? So this becomes the sum of natural numbers, so n into n plus 1 divided by 2 or n into n minus 1 divided by 2. Not quite sure about that, but 100% it's going to be a quadratic equation. So that's why the time complexity of this particular solution comes out to be order of n square, okay? And the space complexity, guys, becomes order of log n, because every time we are iterating this, we are actually, every time this function is being called, we are actually dividing our array into half. So we are only storing n by 2, then we are only storing n by 4, then only, half of it is being stored in the memory. So that's why the space complexity is order of log n. Okay, but so space complexity is not something that we want to worry about. We want to worry about the time complexity. We want to make this solution a much faster solution. Okay, and that's what we are going to do in the next part of this video. So let me first delete this entire code and let's discuss the second approach that we are going to use now. And for that second approach, guys, I want to thank a person. Their name is Chenglai Gu, who has posted this solution in Leetcode, and I'm going to shout out to them and I'm going to just show you guys the exact same approach which has been given by them or suggested by them. Okay, so let's look at this approach, guys. Okay, so this approach is actually going to solve this problem in a much smaller time, and what we are going to use in this case is something called a stack. Okay, so let's see this problem one by one. Let's first of all take this array and I'll put it here, and then we will walk through each and every element. So let's say we are using a stack. The first number that we see in the stack, we just push it into the stack. So we saw 3, the stack is now having 3. Okay, this is a stack of tree nodes, by the way, right? And your tree is also having one single element. Now you see another number which is 2. So what's happening is that once you see a number, the next number which is smaller than the top element of your stack, okay, so the latest element of the stack, which is 3, if you see that the next element, which is 2, is smaller than the latest element, what you are going to assume is that because this element is smaller, I can put it on the left side of my latest element, which is true, right? If that element is smaller than then if the next element is smaller, you just place it on the left side of that, on the right side of that element, right? So because 2 is smaller than 3, it is obviously the child of 3, but because it's coming after, it's obviously the right child. So the right of 3 becomes equals to 2, and then you push 2 also into the stack. Another element comes, which is 1. So 1 is smaller than 2, definitely 1 is the child of 2, but because 1 is coming after 2, it will become the right child of 2. So now 2 dot right also becomes equals to 1, and 1 gets pushed into the stack. Now the issue comes once we see an element which is 6 and 6 is actually greater than 1. Once we see an element which is greater than the latest element of the stack, that basically means that this is the maximum element that we have seen so far. So what we do is we start popping out the entire stack until we actually empty the stack, or we reach a point where the latest element in the stack is actually greater than the current element. So in this case guys, 6 is my current element. What we do is we start popping out the stack, and every time you pop out an element, you know that that element is smaller than 6. So it will obviously be the child of 6. But because that element has appeared before 6, it will be the left child of 6, right? Left child of your current element. So you start popping out until you empty the stack in this case, or you reach an element which is greater than 6, right? So first you pop out 1. 1 becomes the left child of 6. Then you pop out 2, which will become the left child of 6. And finally you pop out 3, which will become the left child of 6. And eventually 3 will be the left child of 6, and the entire stack is empty. So at this point of time, you break your loop, because you now know that you cannot pop out any more elements. So now you take your current element and you push it back into the stack. So 6 is now pushed back into the stack, and you start going to the next element into the array, which in this case is 0, right? I'll probably use here. So the next element after 6 is 0. So once you get 0, you again check which is the latest element in the stack. So because 0 is less than 6, it means 0 is the child of 6. Obviously 0 is appearing after 6, so it's the right child of the 6. So that's why you will just do nothing. You will make 0 as the right child of your latest node in the stack, and then you will push 0 back into the stack. Now the last node comes, which is node number 5, and the 5 node is actually greater than 0. So the algorithm says once your current node is greater than your latest node into the stack, you start popping out the nodes from your stack until either you empty the stack or you reach a node which is greater than the current node. So in this case, what we do is we pop out 0, and once you pop out 0, 0 becomes the so what you do is you pop out 0, and once you pop out 0, you know that 0 came after 5. So obviously 0 will be the left element of 5, right? Once you have popped out 0, it's time to push back 5 in, okay? But what's happening is that once you know that the latest element into the stack, or I would say that the last element which is currently there in the stack is actually greater than the element which is current element, what you do is you take the latest element in the stack, that is 6, and you make the current element its right child, okay? Because the current element has appeared after the latest element into the stack, and it is smaller than the latest element into the stack, so it will become the right child, okay? So eventually I would say it would look something like this. So once you have the 0 into the stack and you get 5. So first what's gonna happen is that 0 will be popped out. 0 will become the left of your stack. So first you will only have this part, and this part will be not there. Okay, first you will only have this part, and 6 will still be connected to 0. Yeah, I mean the right of 6 still will be 0. But once you have 0 popped out and you are about to push 5 back into the stack, you will see what is the latest element in the stack. The latest element in the stack is 6, which is greater than 5. So because 6 is greater than 5, because 6 is greater than 5, what you do is you make 5 the right child of the latest element of the stack. So the current element will become the right child of your latest element in the stack, okay? and finally you will push the current element back into the stack. So again 5 will be pushed back. At the end guys, you can see that once all the numbers are processed, the bottom element of the stack, okay, the last remaining bottom element of the stack is always the maximum element, and that will always be the root of your tree, okay, because all the small elements you are popping out, right, and the last element which was 5 you just pushed in, but the bottom element will always be inside the stack, and that bottom element will be always be the maximum element, okay. So I hope this approach is clear to you through this pictographic representation guys, and now let's jump to the very easy implementation of it. So first of all, to create a data structure stack, we are going to use a doubly ended queue. So we use dq. So dq of tree node. Why we are using a doubly ended queue guys? Because in a simple queue you will not be able to pop out the the latest element from the top. So that's why linked list is going to be assigned to that, so that becomes your stack. Now very simple, we are just going to iterate through all the numbers in the array. Now first thing, once you get a number, you will create a current element with it. So tree node current equals to new tree node, and then you just pass n into it, okay, that becomes your current element. What we now do is we compare this current element with the latest element of our stack. So first we check if the stack is not empty. So if the stack is not empty, then we find out what is the latest element in the stack, or the top element in the stack, stack.peak, and then we see if the top element in the stack, if the value of the top element in the stack is greater than or smaller than the current value. If it is smaller than the current number, or the number n, which is the value of the current node, then what we are going to do, we are going to start popping out the elements until either the stack gets empty or the latest element is actually greater than the current element. And when we are popping out the element, every time we pop out the element, will make that previous element the left node of my current node, because current node has appeared later and the previous nodes were already there in stack. So cur.left becomes equals to stack.pop. Understood? Now what's happening is, now my current node is the maximum node of its own subtree. Now we need to check if the stack is still empty or not. So if the stack is not empty, it means that the element which is now residing on the top of the stack is actually greater than the current element itself. It means if current element is smaller, it should go to the right hand side of that higher element which is currently residing in the stack at the top. So stack.peak dot right becomes equals to current, because current element is smaller and the latest element in the stack is higher than the current element, okay, and that could also be your root element, right? And then finally, when this entire thing is done, we are just going to push our current element to the stack, right? So stack.push current element, so that it can be compared later with other next elements. And when this whole for loop is completed, what we are going to do is we are going to check if the stack is empty or not. Because if the stack is empty, it means there were no elements in the stack ever, right? But if the stack is not empty, it means that whichever element is at the bottom of the stack, that bottom element is always the maximum element, because it will remain inside. You know that only the small elements are being popped, but the higher elements are never being popped. So the highest element will always be at the bottom of the stack. So stack.remove last will always going to be the bottom element of the stack, which was never popped. Let's run this code, guys. Let's see if this works for our cases. Okay, I forgot the new keyword, so that's my bad. Gonna quickly add it, new. Let's run this code again. And we got an incorrect answer. Let's see why did that happen. So we do have our tree node created, right? We do have, okay, so this is a wrong, right? I'm using if statement while this should be a while loop, because what we are doing is we are keeping popping out the elements until the stack is empty or the latest element is greater than our current element. So this until thing will only work if you have a while loop. It will not work in the if statement, right? If statement only runs once. However, once this while loop is completed, then we check if the current stack is not, if the stack is not empty, because if it's not empty, then we just need to check the top element. We don't need to check the rest of the elements, right? Then we don't need a for loop. So now let's run this code. And now you can see the cases are accepted, guys. You can see the results and pretty much they work better. Now let's jump to the time complexity. So here you can see, guys, that we are only using a single while loop, and this will actually give us an order of n time complexity, and this will also give us a space complexity of order of n, where we are pushing all the elements. I mean, not exactly order of n, but you can think of it in that way, guys. You can see that at one point in time, half of the stack is still there, so n by 2, right? But it will still be counted as order of n, so that's why I'm saying that it's order of n. Okay. And then for every single element, guys, like for every single element, this for loop is running, and then whenever it runs, it is only taking out the elements which are there previously. So it will still be much quicker than our previous solution where we are doing a quadratic equation. Okay. So this is the solution, guys. I hope you guys like the solution, and I hope it helps you in your coding practice. And I hope you understand that why do we need to always think about not just the brute force approach, but also how we can optimize it. But thank you so much for watching, guys. If you like this video, if you like this solution, please don't forget to like this video, share this video with your friends, and if you have any questions, comments, suggestions, feedback for me, please do write down in the comment section below. If you have not yet subscribed to my channel, guys, please do subscribe, hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.